Hello friends, welcome to my channel. Today we are going to start vector. In this video, I'm going to discuss scalar, vector and matrix and their role in machine learning and also in computer vision. So let's start. So you can see over here that I have mentioned something like hierarchy in scalar, vector and matrix. Okay. Okay. Differentiate, then think about dimension. Okay, wait. This will come over here. Now from here it will start. Okay. So what is scalar? Scalar is just a number. Like whatever you mention, suppose one, two, three, or it can be negative number, it can be a floating number. In Python, we know that there are some data types like int, that means int, float, and also complex. So if there is only a single number, then it will be counted as scalar. That means in physics we have learned that sorry, if an point actually the scalar quantity means it has only magnitude, no direction. But if we talk about vectors, or let me give you an example of a scalar. Suppose you have a brick, okay, then a single brick will be counted as scalar. Now, let's go to the vector. We have already gone through list, I mean the data structure of Python, which is list. And in list, we have seen that there are so many numbers. I mean, suppose I am talking about a homogeneous list, and this homogeneous list is containing only the numbers, because actually vector is not going to hold any other data type like str or like boolean. It is only going to hold int. That means, or int, or even, I mean, negative integer or positive integer, it can only hold. So vector is a list. It's a type of list, you can say. That means you can see that here I have mentioned three elements, and if you not think about vector, then what you will call it? You can call it a array of three elements. I mean, an array which contain three elements or three items, or you can say this is a list. So the same thing is going to happen over here, and that means vector is a list. You can see what I mentioned here, a list of numbers. Uh, Imagine a single column or a single row in a spreadsheet. Suppose I'm putting so many bricks in a single line. It can be a row, it can be a column. So it will be considered as vector. It, like scalar, it represents magnitude. Also, it represents direction. Okay. What is matrix? Matrix is, suppose you matrix is nothing but, suppose you have taken three or four vectors, and you are putting in all the vectors in a in row and column, then it would be considered as matrix. Okay. So if I talk about an example of matrix, then it would be something like this. So matrix is, that means this is your one vector, this is your one vector, okay, and this is your another vector. And if I take these two vectors line by line, then it would be considered as matrix. So if a vector is single list, a matrix is collection of vectors joined together. This is actually the matrix. And I was talking about the matrix. Okay. So if I talk about the difference, I mean the key difference uh, between all of this, then a vector tracks one set of attributes. Like it can be height, it can be weight, or you can say, suppose here I have given example. If I don't write here one, then suppose I'm giving here 15 something, then you can consider that 15 as a height and 2 as a not consider as 2, let's consider as 20 or 22. So it would be weight, and 3 would be age, not 3 should, like 13. Okay, so this is a collection of a person's height, weight, and age. So okay, but a matrix tracks those same attributes for multiple people simultaneously. Suppose I have just mentioned one people height. This would be 15 would be my height, 22 would be my weight, and 13 would be my age. Okay, this is for single person. But I want to store the same thing, that means height, weight, and age, for so many people. Then what I will do, then matrix will come, and we can with the help of matrix we can create the you can see the diagram, or we can store all the records of so many persons in that order, that means height, then weight, and then age. Okay, so it will be helpful. And now if I talk about computer vision, I mean, what is the role of vector in computer vision? So, in generally in computer vision, a vector is how a computer sees an image feature. Actually, when I was learning this topic, I came through this line, that means computer sees an image features. Then I understood maybe 2 years or 3 years ago when I was learning. When I started the computer learning, then my teacher taught me about the color combination, which is 255 comma 0 comma 255. That time I didn't know that what is this, I was just learning. But today I understood that what is the 255 comma 0 comma 255, or 0 comma 255, like this is a color combination. So this is actually describes computer vision, or you can say this is a relation between this this topic can if you understood this topic, then you will be clear with the role of vector in computer vision. So let me start. Computers does let me tell you, the computer does not see colors. I mean, it cannot understand white, black, blue, anything. Okay, or shapes also. Suppose it's a dog, it's a cat, or it's a rat. It doesn't matter. They cannot understand. They see numbers. They only work on numbers. If you have a teeny grayscale image, that is actually 2 cross 2, or you can say, I mean, this a 2 dimension pixel. That means it would be something like this. I mean, like this. I mean, it will be the first vector and the second vector, and it will be combinedly, you can say it as a matrix. So it will be 2 cross 2 pixel. That means there will be 4 colors. Actually not 4. It will be something like it will look like this one. Let me write over here. So, or I can write here also. Wait a minute. I can write like this. It will look like this. I mean, 2 cross 2 pixel. Pixels. Pixels. Okay. So if you okay, the computer doesn't see a square. It cannot, actually this is a square matrix, but computer cannot understand this. Okay. So what will happen there? It sees a vector of 4 numbers representing brightness. 2 cross 2 means there will be 4 numbers. You can see this is the 2 cross 2 matrix. That means, I mean, there has 2 column, sorry, 2 row, and then 2 column. So it is actually a 2 cross 2 matrix, that means square matrix. So computer only understand that yes, there are 4 numbers, that means 3, 4, 8, 9. There's only 4 numbers. Okay. And I mean, it says that 4 numbers and representing brightness. These all numbers are representing brightness. Computer don't know about colors, but we are indicating with the help of these numbers that yes, this would be my brightness. Whenever you increase your brightness in your mobile, then also this is, I mean, this is working behind the scene. And also, suppose you are filtering your picture, and or you are taking in a snap in a a Snapchat, you are taking a snap. Uh, so there also it is working. I mean, always computer or apps doesn't read your image or anything. It just work on numbers. So now let's talk about the feature vector. Okay. So if you want a computer to recognize a face, suppose you have mentioned that, I mean, you have given this number, then it cannot recognize your face. But if you want to recognize that, you want that this computer should recognize your face, then you have to, what you have need to do, like this in vector, what we are doing, we are passing the first would be my height. I mean, I'm just storing a person's height, weight, and age. So in the same manner, you have to give the first would be your distance between eyes. It will start from top, so you have to pass the distance, I mean the distance between your eyes. Okay, the length of the nose, suppose it will be your length of the nose, and then the third would be your curve of the jaw. Okay, and these three numbers you are passing through list, I mean in a vector form. um Sorry, wait a minute. And then after providing all these details, now your computer can understand, yes, this is your face. And this is not going, you are going to do this. Okay, this is already happening behind the scene. You don't need to worry about this. The developers already developed the apps in that way, so that you don't need to work hard. They can understand by themselves. Okay. Okay, so next point would be your color space. Okay. So a single pixel is often a vector of three numbers: red, green, blue. That means it will something like that. Here, suppose this is my matrix, and it will take you. The first would be red, second would be your green, and third would be blue color. Okay, so these are three colors. So this is actually color space, and the combination of these three colors we can often see. I mean, whatever color you are seeing, this is a combination of these three colors. That means what the ratio in which you are mixing these color, that is going to affect on your image. So the let's talk about the machine learning part. We have done about the, I mean, we have already talked about the image. So this was about the computer vision. Let's talk about the machine learning. So machine learning is essentially matrix multiplication. Okay, suppose that like something, there are so many data, so it will be stored in a matrix form. I mean, there will be column, there will be rows. Okay. Mm, suppose if we talk about weights, the knowledge. I mean, you have so many knowledge. Okay, I mean, suppose you have knowledge about Python, you have knowledge about the Django, you have knowledge about HTML. Okay, so the AI learn. I mean, so what you will do? You have to put your knowledge in this way. I mean, in the matrix form. There are a lot of type of knowledge, so it should be like this and in the matrix form. So let me talk about the AI part. So the AI learn is also stored as a matrix of weights. What was the process actually? When the AI, suppose you are asking a question, okay, and then what is happening behind the scene? Wait a minute. Okay, let's continue. Okay, so we were talking about the process. So suppose when the AI makes a prediction, okay, so it performs a mathematical operation like dot product. Not it will not perform the cross product. We know that in vector there are actually two type of mm, cross. I mean, one type of cross product and the other is dot product. So dot product is usually we do for scalar, but we also do for the vector. So here also we will perform dot multiplication. Hmm. So AI will do the same thing, and then it will actually do what? Um, it will do the same thing, done the same operation on between the input vector and the weight matrix. That means, suppose you have there is a very important line if we say about if the vector is a question, okay. If suppose the vector, so you can consider this vector also, no? So suppose or here you can consider this is a vector, okay. So if a vector is a question and a matrix, this matrix is a rule of the world, okay, rules of the world, then if you multiply this matrix to this vector, then you will get your answer, okay. Let me tell you again. So suppose this is your question. I mean, in the life, suppose this is your life and you have a question. So the question would be like this, and you have some rules to solve that question. So this rule is that one, this matrix, and when you will multiply this rule of solution, or you can say, to the vector, then you will get your answer. And let me run this, let me show you this program. Here I am working on numpy, because if we use numpy, then we don't need to perform so many tasks over there. I mean, if we don't go through numpy, then we have to write a long code. I mean, very, it will be long or large. So that's why I'm avoiding all the things, and I'm using numpy over here. So with the help of NumPy, you have to write like this one, import NumPy as NP. I'm taking it as NP. If you want, you can use some other word also. You can put your name here also, but I am putting here NP. So this is my I'm taking a vector, and actually I have told you that vector is nothing but an array or a list. So this is my list, and this is one dimensional, and I'm also taking a matrix which is two dimensional, and when I will multiply both, then the result would be something, and you can see the result. But before showing you the result, let me show you something else. Okay, wait a minute. Mm, okay, so let me show you in image. So here you can see this is my vector. I have taken a vector. This is one dimensional, and the next, which is a matrix. So this is a two-dimensional matrix. Okay, and actually vector start and vector is two-dimensional also. And if we talk about the three dimension, then it would be tensor. But right now we are talking only about the vector and matrix. So if we go to multiply, or we are going to perform the dot operation, then what will happen? So first you will write your matrix, and then you will write your vector. Hmm. And then you can multiply. That means you have to multiply like this: 6 multiply by 2, okay, plus 7 multiply by 3. Then you can write like this, okay. And again 9 multiply by 2, okay. Let me do something over here, like it will be easy to understand you, okay. So 6 will first multiply by 2, okay, and then you can see over here, you can write, you will write over here like this, okay. Then again you will give a plus sign, and then 7 will multiply by 3, and then you will write over here 7 into 3. Okay, next I'm just telling you a simple, very basic concept of multiplication. Okay, and then you will do the same thing for 9 into 2, and then plus 8 into 3. Okay, and now you will get the answer like 6 into 2, that means with 12, and then it would be 11, sorry, 21, so 33, and then 42, in this way. So let me clean all the things. Clear all diagrams, okay. Now, so in this way you can solve a dot operation. I have just shown you, and now I'm going to sorry, now I'm going to run my execute my program. So you can see the answer over here, 1126. If you notice that sorry, it's not matching with my image. Why it's not matching? Because I have taken another number in my image and this is something different. You can see this is 2 3 6 7 9 8, and here I'm taking 1 2 3 4 8 9. So when you will multiply this, and you will get the same answer that I am getting over here. Okay, that means 11 26. Try it by yourself, and then tell me that if there is any problem. So now we will talk about the 3 cross 3, which is actually a tensor. So this is a image matrix, actually a matrix, but this will be considered as tensor also. Mm, so let's talk about this. We have already implemented all the things in the program. Now, wait a second. Mm, what was that? Okay, so before talking about a 3 cross 3 matrix, let me tell you that in this program, here we are going to do what? We are going to check the 3 cross 3 image how a image represent, okay, in pixel. So, hmm. So let me start with this. So here we have a color combination. You can see this would be, let me first uncomment the lines and then I will explain you. Hmm. So you can see that here 255 means white, 0 means black, and again 255 means white. So I am taking a array, and which is a 3 cross 3 matrix, that means 3 dimensional, and I'm just going to print the matrix and you will see the result. In the result you will again get the matrix also. So let me first run, let me execute the program and then you will be um, wait, let me check that there is some error, maybe syntax warning. List list one list indices must be integer or slice, not tuple. Perhaps you missed a comma. Okay, I missed a comma. Yes, I have missed a comma. So there would be a comma. Okay. Mm, now, in the last, I don't need to pass a comma. Okay. So now it will work. Let me again execute the program. First, let me clear the screen. There was a comma missing. That's why that's why we were not able to see. And if I comment this one, then it will be good. Okay. Hmm. Now let me again execute the program, and you can see this is a metric that we are going to have. Okay, and how it's possible. So let me tell you that this is actually if you imagine a teeny image of dark cross on a white blackboard. I mean, you have a white blackboard and you are just giving a black spot like this. I mean, dot, black dot, you can say. So So, so computer, how computer can understand? So to understand the computer, you have to give something like in this format that yes, computer can understand this. Yes, this is a teeny dot, black dot on a white blackboard. That's why you can see that all are white and the maximum color are white, and there are some black spot over there, so that computer can understand in this way that yes, you have passed and this is your teeny black spot in the white board. Okay, so I have already told you about the programming, in this program. Okay, and now what should I say next? So let me talk about the flattening. Okay, so let's talk about the flattening. So sometimes it happens like mm, wait a second. Okay. So in machine learning, most basic models can't read uh, 2G read 2G 2G grid directly. That means they prefer one long line data. So we do something called flattening for this, so that computer can understand, okay, which turns our matrix into a single vector. That means suppose if I have a vector like 3 cross 3. Mm, yes, I have a vector 3 cross 3. Hmm. So now let me stop this one. So, okay. So this is a matrix of 3 cross 3, but I want to convert this matrix into a single vector. So how will I do this? So for this reason, I need to convert this into a single, I mean the 3 crosses. So I will something do like something 9 cross 1. So now it's a single vector. That means now computer can understand easily. And why it matters to AI. So suppose once your image is a vector, that means in this form, then the computer can compare it to other vectors, like it will match with other something. Suppose like there is a color combination of red, black or blue, or only white, white and black. So it will match that at which position the number, suppose at the first position there is a number called number 255. Okay, so it will match with that image. And if some suppose the of an if an image have a number at the starting 0, so it will compare with that image also. Okay. So whenever we apply filter, or we go to blur our image in mobile phone or in any camera, then what happen? Then we actually multiply our images matrix by another small matrix called a kernel. Okay, this is actually kernel is some I will explain it again, but my focus is to just give you the basic knowledge about the differentiation. That's why I have created the video about the differentiation, the about the chain rule, and the relations between machine learning and differentiation, also computer vision. And today also I'm recording a video for the vector, so that I just want to make you understand the basic part. I know the further you can study, but I'm just giving you the basic knowledge about all of these things. Okay, so this is all about for today, and in the next video we will cover some other point. Thank you very much, and stay happy and healthy, and keep practice.